Hello everyone, welcome to Code and Learn. So Go 1.25 is scheduled to release in August 2025 and it brings a number of significant improvements and new features. The release is mainly focused on performance, efficiency and developer quality of life improvements. The major update is the JSON v2 package, which brings some really impactful changes. Let's have a look at all the changes coming in Go 1.25. I'm going to use a different approach this time. Along with the theory, I will also go through the code with the relevant changes. So if you want to try it along, you can install the release candidate 2 for Go 1.25 using go install golang.org/dl/go 1.25 rc2, the latest version. Once this is installed, you can do go 1.25 rc2 download, which will install the binaries required for running Go 1.25. And if you want to try experimental features like JSON v2, you can just do go experiment, export the environment variable, do go 1.25 rc2 run your program.go. So here I'm going to do go install golang.org/dl/go 1.25 rc2 at latest. Once that is done, we can do go 1.25 rc2 download, which I already have downloaded. With this, you can have the regular Go version installed on your machine and the rc2 as a separate binary, which makes it easier to test the new features in isolation. So if I do Go version, you will see it still exists and I'm on Go 1.24.5. If I do Go 1.25 rc2 version, you will see it's calling 1.25 that I have installed in isolation. With that done, let us look at the changes. So the synctest package has gone under some changes. Instead of the run function that we used to use in the previous version to run the synctest, now a new test function has been introduced while run is being deprecated. The test function runs a provided callback or a test function in an isolated bubble. Any Go routines started within the bubble are also part of the bubble. Why are we talking about the bubble? Because within this bubble, the time package uses a fake clock. So each bubble will have its own fake clock. The time in the bubble only advances when every Go routine in the bubble is durably blocked. If you have something like time.sleep or any operation that sleeps for or that blocks for a given timeout, it should return back immediately, which helps with testing. So you don't have to wait for like 5 seconds in a test if your program is sleeping for 5 seconds. Then we also have synctest.wait. When you call synctest.wait in your bubble, it will block until all the Go routines started inside your bubble get unblocked. Few examples of durably blocked Go routines are a blocking send or receive on a channel created within the bubble, a blocking select statement where every case is a channel created within the bubble. Then you could have sync condition wait, sync WaitGroup wait, or time.sleep. Operation blocking on IO are not considered durably blocked. Now let's look at a code example. Here you can see I have a sleep function in the concurrency package which is doing nothing besides sleeping for 5 seconds. Now if I go to sleep test, you will see I'm testing sleep. I have two tests here. First one is using synctest.test where we are just sleeping for 5 seconds and just logging the time it takes. I am failing the test here because otherwise the log statements won't be printed. Then we have a similar test for wait where we are waiting on the Go routine that we start inside the bubble to be completed. So here we should get true because the Go routine is changing the value to true from false. And with this one, we will see that it will return within few milliseconds without sleeping for 5 seconds since we are using a fake clock. So it makes it easier to test functions like these. To make my life easier in the makefile, I have the run target which is running with go experiment JSON v2, which we will look at later, go 1.25 rc2 run main.go. Here I will add the test target as well. For test target, I will just do go 1.25 rc2 test and then test everything we have. Save it. Now let's try to run it. Make test. And as you can see, it only took few milliseconds to execute. That is the sleep test. Since we are using a fake clock, so it's not actually sleeping for 5 seconds. And in the wait test, we are getting true printed because we have synctest.wait, which will wait for all the Go routines inside this bubble to be executed. Now if I do func test sleep legacy, which is basically similar to this, but I'm not using synctest. So I will just do something like this. Now let's try running the test again. Make test, and as you will see, the test is hanging up because we are actually sleeping for 5 seconds. It took 5 seconds to execute this test, but with the fake clock, it only took few milliseconds. So that's the use of synctest package. Now let's look at some of the changes coming through the encoding JSON v2, which is the experimental package being introduced in Go 1.25. One of the most exciting features of this is the new options for unmarshalling and marshalling behavior. These options allows you to customize behavior without implementing custom marshal JSON or unmarshal JSON methods for every minor change. That is, to introduce any custom behavior in the marshalling or unmarshalling, you don't have to implement the marshaller or unmarshaller interface. I know theory is boring, so let us go back to the code. Let me close this and the terminal. So I have code already written here. I'm just going to uncomment it and explain to you as we go along. For this to work, we need to import the experimental JSON v2 package and also the JSON text package. Let me do that quickly here. So with the import set, let us look at the emoji marshaller. Here I'm using the marshal2 function from the new JSON package to introduce a custom marshalling behavior. Marshal2 function accepts a callback function where we will get an encoder and the value, which in our case is a string. So every time we get a string, we check if the value is yes or value is true. We want to marshal it into a smiley emoji. If the value is no or the value is false, we want to marshal it into an angry emoji. For all other cases, we want to skip to the next marshaller, which can be done using json.skipfunc. So this is our emoji marshaller. Now let's look at the bool marshaller. In here, I'm doing a similar thing, but instead of accepting a string, I'm accepting a bool value. If it's true, I encode that to JSON text.string, oh yeah. If it's false, I encode that to no. Next, we are going to merge these marshaller or the marshal2 functions into marshal options that can be supplied to json.marshal. So we merge the two and then we have this value slice, which is true, of, no, hello. Next, we are going to marshal these values providing along the marshallers we implemented. So now if I do make run, that is go experiment JSON v2, go 1.25, run main.go, you can see value true was marshaled as oh yeah, off was marshal as it is because we are not handling this case here or in both of the functions that we implemented. And then we have an angry emoji for no and hello for hello because again it is not being handled by these two marshallers. So basically that's how you can implement custom behavior with marshal2 functions. Then we have the new behavior for nil slices and maps. Earlier you would get a empty map or an empty slice when you had a nil slice or map in your struct that you were encoding. But now there are new options that enable you to marshal nil slices and maps as an empty array or as an empty JSON array and an empty JSON map or object. So let us look at that. First, I am commenting out the data structure that we are going to use. So we have a data struct which has items and meta. Items is a slice while meta is a map. Then we create an instance of it. Now let's comment this out, which is we are marshalling D into JSON. So we should see something like this printed to the console. Let's try this out. Clear the console, make run. Log is undefined, so I'm just going to save it, which should automatically import it. Make run again. And as you can see, items was a empty array and meta was a empty map. Now to influence this behavior, we can use JSON format nil slice as null, similar to which there is format nil map as null. So this time we should see items as null and meta as null. Clear the console, make run. And as you can see, in the second print statement, we are getting null null for both items and meta, which are nil slice and nil map in our Go struct. So with this, you can control this behavior. Next, we have the case sensitive unmarshalling. The new option JSON match case insensitive names or tags case ignore can be used to ignore the case when unmarshalling from JSON to a Go struct. Let us look at this example. So I'm just going to use this uncommented. First, I'm creating a person struct. And as you can see, person has first name. We map it to first name where name has a uppercase N. Then we have age, map to lowercase age. Now if I supply this, these don't match to the tags because they have different cases. So when we are going to unmarshal this, you will see they are not unmarshaled properly and we will get 0 value for the first name that is a string and age which is an int. So first name should be empty and age should be 0. But in the next one, what I'm doing is I'm using the same data that is JSON input, but this time I'm supplying a JSON.match case insensitive names true, which means when Go is going to compare the tags to the JSON, the case will be ignored. So we should have the expected values. Let's run the code again, clear the console, make run. And as you can see, in the first case, we are getting 0 values, while in the second case where we supplied the match case insensitive names option, we are getting the values populated. This can also be achieved by using a JSON tag called case, where you can do something like case is equal to ignore. So with this done, you will see in the first case, we will have at least the age unmarshaled to the Go struct. So make run. Oh, sorry for the error. I just had a typo in here. So let's try again. Make run. And as you can see, in the first case, at least the age has been populated. I'm just going to clear the console. Next, we have the byte marshalling tags. In the previous version of JSON package, that is the JSON v1 package, marshalling a byte slice will lead to it being translated into an array of numbers in JSON. In the v2 package, a byte slice is marshaled as a base 64 encoded string, which is a preferred way for representing binary data. You can also use tags such as array to get the same behavior as v1. Let's look at the code. Let's just uncomment it what I have here. So here I have a binary data which is a struct having two fields, data and raw. Both of them are byte slices. The first one should be encoded into a base 64 string, while second one should be encoded into an array of numbers which represents the byte values. So let's try it out. Make run. And as you can see, in the first case, we are getting a base 64 encoded string, while in the second case where we added format array tag, we are getting the byte slice as a numbers array. This is an option that can be used for representing binary data as you need. Then we have the new format tags for time.time representation. You can specify common formats like RFC, 33, 39, Unix, etc. to direct the marshaller on how the time should be represented in its JSON form. Let's look at the code. I'm just going to uncomment this. Here you will see I have this even struct where I have two timestamps, that is timestamp and Unix epochs. I'm representing this in JSON with timestamp and Unix_TS. Here, these are the tags that I'm using, that is format should be RFC 3339 and format should be Unix for Unix epoch. Now let's look at the output. Clear the console again, make run. And as you can see, in our first case, we got a timestamp in the RFC 3339 format, while in the second case, we got the Unix epoch time. So this way you can customize the behavior of marshalling timestamps with the JSON v2 package. Along with these, JSON v2 introduces improvements in the performance. It's often 2 to 10 times faster, especially for common struct types. Many common unmarshalling scenarios will result in zero heap allocation. This is a huge win for the garbage collector. Also, the error messages from JSON v2 are designed to be more informative, providing better context about where a parsing error occurred within the JSON input. Again, if you want to try it out, you would have to use the GoExperiment environment variable. Another useful change is with the sync.WaitGroups, which now introduces the Go method. Let me explain you with the code, which will provide you with a better context. So here, I have a WaitGroup variable and I can directly call the Go method on this WaitGroup to run this function, that is the callback function I provide in a Go routine. If we look at Go, you will see it's basically a wrapper of what we used to do earlier, that is WaitGroup.add1 and WaitGroup.done inside the function. With this, you don't have to keep doing WaitGroup.add where you need to keep track of the number of coroutines you are starting. Instead, the Go method will do it automatically. Another thing, you don't need to call WaitGroup.done inside this function because that will conflict with the automatic behavior of Go and decrement the counter or decrement the internal counter of WaitGroup to a negative value. Let's try to see if this works as we expect. So we should expect all the 3 Go routines to be executed. Make run. And as you can see, all 3 were executed with the new Go method. Keep in mind that you still need to call WaitGroup.wait for them to be executed. The biggest change in the net HTTP package is the introduction of cross-site request forgery protection with the http.new cross origin protection. cross-origin protection implements protection against CSRF by rejecting non-safe cross-origin browser requests. It provides you with a handler that can be used to accomplish what you want. Let's have a look at the code. So here, as you see, I create a servmux with mux, then define few routes with the handler func on it. Now to cover these against CSRF attacks, what I can do is create a new cross-origin protection from the HTTP package. With that, after creating this, I can add trusted origins to it. Then we can use the handler method to cover our mux. That is, we are covering these two methods under CSRF protection using the handler. So now, if our server gets request for any domain name that is not example.com or doesn't end with example.com, these requests will be rejected. So cross-origin protection gives you the security of protecting against CSRF attacks out of the box, which is a nice feature to have. Then we have the change with the reflect package. The new TypeAssert function allows direct conversion of a reflect value to a go value of a given type, avoiding unnecessary memory allocation compared to value interface followed by a type assertion that we used to do in earlier versions. So here I have the code. My interface is the interface value of type string. Earlier, you would do something like this. That is, first get the value of my interface with reflect.value of. Then you would perform a type assertion. Now these two steps can be done in a single step. That is, I can assert on the value with TypeAssert, provide the string value and assert it's a string value. Similarly, I can do something with the int value. I can provide int here and that would be converted to a int value. So basically, Go is internally using generics to make our life easier as a developer. Let's try it out to see if it works as expected. Make run, and as you can see, the new way is working as expected, similar to the older one. But it's much easier to perform. It has performance benefits of avoiding intermediate allocations. Another big change coming through Go 1.25 is the automatic handling of GOMAX processes. If you don't already know, GOMAX processes can be used to configure the number of processes that your Go program uses. On Linux, the runtime considers the CPU bandwidth limit of the C groups containing the process, if any. If the CPU bandwidth limit is lower than the number of logical CPU available, GOMAX processes will default to the lower limit. This is very helpful when your application is running in a container runtime like Docker or Kubernetes. If you don't already know, C groups are a way of Linux that enabled containerization of processes. So if you're running in a Kubernetes environment, you will set the limit on the number of CPUs that your container should have. With this change, that means your Go program will automatically adjust to the number of processes it has, unless you have manually set the GOMAX processes via the GOMAX processes environment variable. On all other OSs, the runtime will periodically update GOMAX processes if the number of logical CPUs available or the C group CPU bandwidth limit changes. So it will automatically update the GOMAX processes according to the change in the system limits, which means your application is not going to overload the system. Next, we also have an experimental garbage collector. The garbage collector's design improves the performance of the marking and scanning small objects through better locality and CPU scalability. Go team estimates that the performance improvements are somewhere between 10 to 40%. If you want to try it out, you can enable it by setting co-experiment green T GC at the build time, which will enable this new garbage collector in the runtime of your application. We also have changes to unhandle panic output. Earlier, if a program panicked with panic something, but then recovered and then repanicked with the original value, it would be printed as panic, recovered, panic, panic again with the original value. But now, it will print something like this, that is panic, the original value, and you will have recovered and repanic. So these were some of the major changes introduced with Go 1.25. As you saw, lots of changes have been made to existing packages to make our life easier as a developer. Along with this, Go 1.25 also introduces performance enhancements for hashing functions. Hashing is now 2 times faster for crypto SHA-1, similar with SHA-3, and RSA crypto generation. Improvements also have been made to file system and I/O. In the OS package, under the root type, you get new methods such as root chmod that gives you better flexibility. Then we have addition of attributes with testing and slog. I'm not going into details of these because I feel these are minor changes. If you are interested in these, I will add a link to the Go release document so that you can have a look at it. Overall, I think these changes collectively improve Go's standard library in terms of performance, security, and developer experience, solidifying its capabilities for a wide range of applications. I hope you enjoyed this video. I would love to hear your thoughts on these changes in the comment section. I will see you in the next video. Until then, happy coding.